So in the first example, you were asked to either convert a power of 10 into a standard number or a standard number into a power of 10. The way the powers of 10s work are that 10s raised to positive numbers are going to have essentially that many zeros following it, whereas 10s raised to a negative exponent are going to have a number of zeros preceding it. The way I like to kind of remember it is that basically the number you see up here are the number of decimal places that it would take you to move back to having the decimal point right after the 1 again. So 10 to the 14th is going to be a 1 with 14 zeros following it. Whereas 0.00000001 is going to be 10 to the negative 7 because there's 7 decimal places you'd have to move this in order to get this back to being 1. So it's going to be 10 to the negative 7. 10 to the negative 12 means that you're going to have 12 decimal places that you'd have to move from before that with a bunch of zeros in front of it to get back to 1. So that means you're going to need 11 zeros before the 1. So you're going to have 11 zeros and then the 1 following it. Whereas here, this is going to be 10 raised to a positive power. You can count the number of zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So your decimal point's right here. It'd have to move 17 places to get back to making this 1 again. So this is 10 to the 17th. So there's your 17. This is 10 to the 17th. Scientific notation works very similar. This one's showing a decimal point a little bit before its time, but that's okay. Scientific notation is always going to be written as some number that's going to be between 1 and 10, not including 10. It has to be a single digit to the left of the decimal point, times some power of 10. And so basically when you want to convert to scientific notation, you have to think, well, how many spaces do I need to move this decimal point to get a single digit number between 1 and 10, not including the 10, before the decimal point. And so here I'd have to move it to this position here to make it 1.45, and that's the number I want there. This got moved 1, 2, 3, 4, 5, 6. And since it's a small number, I know it's going to have a times 10 to a negative exponent. So those 6 spaces is going to be times 10 to the negative 6. So 1.45 times 10 to the negative 6. Here you can see the decimal point is actually starting here. And you want to move this until this becomes 4.5. Now this is going to be times 10 to some positive power of 10. And you moved it 10 places, so it's times 10 to the 10. For this one here, now you're going the other direction. You have 8.2 times 10 to the 8th. That means that you want to take this decimal point and move it 8 decimal places to the right. So when you start writing this, you're moving it 1 place to get it to 82, and then you're going to need 7 more zeros in order to get it to its position. So that's the number you have, 8, 2, and then 7 zeros following it. Here again, going back to scientific notation, the decimal point is right here. You want to move it back to this position to make it 7.241. That is 7 places, so it's going to be times 10 to the 7th, so 7.241 times 10 to the 7th. This one here, 6.23 times 10 to the negative 10. You're going to take this decimal plate, you're going to move it 1 to the left, because it's negative here. You're making this a smaller number. So you're going to move it 1 to the left. You're going to get your 623, but you need 9 more places to go, so you're going to need 9 more zeros to precede that. And so you're going to have 0.90623. Here you have a small number, so you're going to have some number times 10 to a negative exponent. You want to move this decimal point to this position here after the 5, so you have 5 times 10. Well, you move this 12 spaces, so it should be times 10 to the negative 12. As far as operations go with scientific notation, now generally you know, you could probably do a lot of the stuff that showed in the previous example and this one on a calculator, but ultimately you are going to be asked to show how to do this in its proper stages, because the calculator will give you one answer versus the other, but not readily both. You have to go through a lot of menu items to get it converted in some cases. So the way it's typically done, if you want to do 3.4 times 10 to the 12th times 5.6 times 10 to the 8th, remember 2 parentheses next to each other is multiplication, you're going to multiply the first portions, and then you're going to multiply the powers of 10. So if you do 3.4 times 5.6 and 10 to the 12th times 10 to the 8th, 3.4 times 5.6 is 19.04. 10 to the 12th times 10 to the 8th, according to your rules of exponents, you would add these and get 10 to the 20th. Now, this is currently not scientific notation, because this value to the left of the decimal point is more than 10. So I want to move it one more decimal place to the left, and by doing that, that's going to make me have to increase the exponent here, so it's 1.904 times 10 to the 21st, which is what it is in scientific notation. Of course, I'd have to move it 3 places to the right, and then 18 more places, which means I need 18 zeros to write it in standard. So 1904 and 18 zeros would be the number in standard notation. So it's a pretty big number. It works very similar for division. You're going to divide the two values in the leading position, and you're going to divide the 2 powers of 10. So you're going to do 7.488 divided by 9.6 times 10 to the 9th over 10 to the 4th. 7.488 divided by 9.6 gives you 0.78. And 10 to the 9th divided by 10 to the 4th, you would subtract the exponent to get 10 to the 5th. Again, this is not scientific notation, because this number here should be at least 1. So this needs to move one more place to the right to make that a 7.8, which means that this is going to get subtracted by 1, and you're going to have 7.8 times 10 to the 4th. That's it written in scientific notation. Of course, when you write it in standard notation, this is going to move one place to the right to get it over here, and then you're going to need 3 more zeros to move it 3 more decimal places. So you're going to have 78,000 in standard notation. So again, here, multiplying these two together, you're going to multiply the 6.5 and 2.3, and the 10 to the negative 15 and the 10 to the 8th separately. 6.5 times 2.3 is 14.95. 10 to the negative 15 times 10 to the 8th is 10 to the negative 7th. Again, this is not scientific notation. This needs to move one more space to the left. So you're going to have 1.495. You need to add 1 to this exponent to get a negative 6. So 1.495 times 10 to the negative 6 is the correct answer in scientific notation. To write it in standard notation, you'd move this one space to the left, and then you need 5 more zeros to move the additional 5 spaces to the left for a total of 6. So you're going to have a decimal place 5 zeros, and then 1495. And lastly, here again, you're going to separate this. You're going to do the 3.082 divided by 6.7 and the 10 to the 7th divided by 10 to the negative 4. Multiply those two results together. 3.082 divided by 6.7 is 0.46. 10 to the 10th divided by 10 to the negative 4th, you would do 10 minus a negative 4, which gives you 10 to the 14th. This is a number here, but it's not scientific notation. So this needs to move one more space to the right, and that's going to make you need to subtract this by 1. So you're going to have 4.6 times 10 to the 13th, which is what it is in scientific notation. And then to write it in standard notation, you move it one space to the right, and then you're going to need 12 more zeros to move with the additional 12 spaces. So you're going to have 4, 6, and then 12 zeros following it. So that is the end of this problem, and that's the end of this video. If you have any additional questions, please make sure to bring them up during class.